Okay. Good morning. We are Team SubAutomizer. Firstly, we'd like to thank everyone for attending today on behalf of Danny, Omar, and myself. During this presentation, we are going to be introducing the idea that came to us from our investor, and we're going to just illustrate all the steps that we are taking to meet these expectations and, of course, those of the market. The idea is simple. We are to design a machine that's going to be practical. The machine's going to be, it's going to wrap us up at the end of a food line. It should, of course, be safe, meet all health regulations, and be practical. As seen here, the process flow at a sub shop is simple. You come in, you choose your stuff, but what we're focusing on is at the end, we have some steps like wrapping the sandwich, cutting, wrapping again, and packaging the product. Our machine code named ELA, it's going to take over these steps and facilitate them. But right now, Danny's going to come in and he's going to explain how we're going to achieve this.
As with any machine, our paramount goal is safety, and we tend to accomplish this with possibly using a conveyor type of system. Secondly, it needs to be efficient. So to tackle this task, we tend to consolidate multiple steps into one, mainly being the folding and wrapping of the sandwich. Lastly, it needs to be practical and cost-effective. To handle both of these, we tend to design a modular system which will automate a tedious task. In addition to all these goals, we also want to utilize vacuum sealing technology to prolong the life of the sandwiches. This represents a photograph of a machine that is currently able to be purchased. You will notice that it's rather large, so our goal is to shrink this on a small scale. But this machine also utilizes the same type of technology that we wish to use, being the vacuum sealer and the plastic bags. Omar will now discuss some of the research that has gone into this project.
Since our end product is going to be a global reach product, in other words, it's trying to be viable to the market itself, global scale, we're conforming to the ISO standards. ISO is standing for International Organization for Standardization. 22,000 stands for any food-based process or device. On top of this, we're also conforming to the ISO 9001-2000, which is the quality management arm of the ISO 22000. This allows us to, if we achieve ISO certification, further down the line, it will facilitate OSHA certification and FDA, since some of the guidelines are equivalent. Carlos will now speak on more of the global aspects of this project.
As Omar mentioned, the ISO guidelines make our product marketable globally, but we also have to look at small details such as for safety, we have to use on our machine warning signs that are just understood globally. Most of the world uses SI units. We plan to use English and SI units. We also want to look at guidelines. For example, the European Science Medicine Agency, maybe they have health guidelines that we don't have here, and just by using those, we make our product certified in those countries, Europe in this case. And we also understand that environmental factors are important nowadays. So for our parts, we're looking for corrosion-resistant materials that are going to prolong the sustainability of the product. And for a wrapping medium, it could be plastic paper. We're looking for biodegradable and recyclable parts. So this concludes the research. We're going to move into the design phase, and Omar's going to take us.
For design phase, since this is going to be a device which will eventually be patented, or ideally be patented, we're first going to actually research the market, both domestically and globally, to find out any device that is comparable to what our design is. Secondly, after we do this, since we are given a budgetary and design constraint, we are going to basically get those devices and see what can and cannot be used according to our specifications. Upon this, we're going to reiterate the budgetary again to maintain a high cycle life, which means a longer product, longer device, mechanism life at a lower cost, which is both ideal for the end buyer. This process is further illustrated by the graph shown on the screen, which shows both from initial inception, which is September 18th when we first met with our investor, to current and forecasted process designs. If you notice from the date, we actually have a cost and conceptual design already met, but Danny will speak more about this.
So this concept sketch embodies all of our preliminary ideas. The idea is that the sandwich will be placed at the beginning on the conveyor system, where it will ultimately be vacuum sealed at the end of the line, being folded along the way. The next slide represents our preliminary budget analysis. You will notice that the most expensive items thus far that we predict are going to be the machining as well as the use of stainless steel materials. In total, this is approximately $5,000.
Now we will now open the floor for questions. Are there any questions in the audience?
How much does the system that you showed us cost?
It's actually, we only get estimations. They don't want to say price, we have to contact, but what I got from estimations was around 35,000. And that was pounds, because that's actually UK.
Let's go back to your conceptual side. Okay, one question I want to throw out here is cleanliness. How are you going to clean this? How are you going to maintain it?
That was actually one of the main things. We also had a problem with, obviously, if you see it's rolling. So the bearings themselves, we can't use hydraulic system, which is one of our investors' initial designs, but we had to throw it out. The hydraulic system's leaking. So what we're doing with this is actually using a food-safe conveyor belt that is able to be disassembled.
So all of those leaflets can be opened up and cleaned?
At places like Quiznos, they already have conveyor belts that are available. So we know they exist and we can use those.
It's able to, it's enough to be deconstructed. We're able to deconstruct it, and most restaurants have a food quality dishwasher which exceeds the temperature, so we'll be able to sanitize. But again, we will take that is one of our main concerns.
So when you bring us a prototype, I want to see you take it apart in front of us. Because that's what's going to happen in
Yes,
reality,
that
is
is
that
very true.
you're going to need to have some hourly individual come in and tear it down and put it back together again, of course.
Any other questions?
Is the size, what is the approximate size of this?
Oh, that's an excellent question. We're trying to, since we're adapting to current space, we're minimizing the size to 14 by 14, which is around more or less what most, we're using Subways, but most Quiznos or Subways or any other sandwich shop usually have. It's a 14 by 14 square.
And do you anticipate that being disassembled to go into the dishwasher?
Yes. Well, certain parts should be disassembled to go in the dishwasher. The other parts we're going to try to make it easier to clean by either rag or chemical product.
I reiterate the concern of this gentleman about cleanliness.
Yes. And that is one of our main concerns, and it's actually one of our main goals.
What about the maintenance aspect of this machine? What's going to fail and how easy is it going to be to repair?
Yeah, this is why we want to do it in a modular system, such that if a part were to fail, the replacement will be fairly simple, we would hope, and cost-effective, hopefully. So, as with any moving part, they can fail, so we want to keep it to as minimum as we can, but there's some things that we aren't going to be able to avoid, such as the rollers and such.
The maintenance people can tank a job.
Yes. We're going to make it as simple as possible, just to facilitate that.
You're doing sub-folding, and I'm going to show my ignorance of lack of international travel. Does everybody eat subs around the world?
You know what? That's a good question. No, not everyone does.
So I don't know if you have global reach for sub, perhaps for a
But
wrap.
there are Subways all over the world.
Yeah, they are.
Now, does that mean that not everyone eats subs?
Consider that.
Isn't Subway the #1 restaurant?
Yeah.
I don't know.
Yes.
I think Subway's the most.
It is over McDonald's.
Yes. At the very least, I don't know if they all have sub sandwiches.
Yeah.
Okay.
No,
Sure.
you said about having a long life at low cost, right?
Yes.
What's the long life? I mean, what you're expecting would be the definition of a long life?
What we're trying to do is shoot for around a 5-year lifespan. Again, that's our minimum. If we could go above that, that would be fantastic. But a 5-year minimum, 5-year for the cost would be fantastic. We haven't done the benefit-cost ratio analysis yet. But once we do that, we'll be able to actually we'll be able to fine-tune an actual lifespan of the product to both accommodate the buyer and as well as the investor. Yes.
Are you going to be benchmarking against the larger units that are already on the market, or are you benchmarking against labor?
What we want to do is we feel what the investor said in the beginning is that he feels that you need a person to prepare the sandwich, but you don't need a person to take the time when you're busy and do this tedious task. So what we want to do is go against, just give the employees more time to work on what's important. But what we showed earlier with mass production, that's really something we're not competing against, because that's for packaging and selling at supermarkets and something else.
It's too large to actually, it's too large to be comparable with ours. Ours is going to be a large reduce to aid in that and to aid the employees or the sandwich artists.
So you're competing against the labor.
Aiding them, I like to use that word actually.
Well, but.
Supplementing.
So-
Thank you, supplementing, yes.
I mean,
Okay,
if it's cheaper and easier for them to just fold this up and put it in a bag, obviously, they're not gonna buy this device, right?
Exactly, that's
So
also
you're
another part
competing
of the
against
cost
labor.
benefit we have to
Yeah.
analyze.
So that's what you guys have to prove all throughout, right?
Yes.
You have to make sure that the cost of purchasing this machine will reduce some other aspect within the restaurant to make that business owner buy it.
And your labor costs vary dramatically
Yes,
around the world, so
absolutely.
your viability might not be global.
Right.
One real quick comment.
Yes.
I also would like to see a risk assessment, because you've got a conveyor going with a heat source, and you've got a continuous moving, you've got a heat vacuum sealer.
Well, the sources are isolated, it's very.
Well, I want to make sure that I don't have a bunch of people putting stuff in, and the next thing I know, I lock up the machine, and I
You get
start
your finger in the heat seal, right?
throwing
Yeah.
heaters,
Yeah.
burn down the place. So I need you, I'm thinking you need to do a FMEA, failure mode effects analysis, to ensure to us that you've got mitigation to any potential safety concern.
Yeah, well, we have researched some heat sealers that actually, when you put your hand in there, they actually move back just for that, but we have to do further research.
That's fine.
Yes.
Are there any other questions?
Thank you very much.